In this video, we'll be talking about how we use Git for CSE 480 projects. Okay, so why are we doing stuff in Git? Well, the primary reason is this is how you'll be turning in your projects in all 6 projects for CSE 480. The only way to submit your projects either on time or late is to push code to a private GitHub repository that we've made for you for this class. So it's important to both understand how to use Git in order to turn in your projects, and also Git is a really useful tool to know beyond the purposes of this class. In fact, in many ways, Git might be the one thing that you learn from this class that you'll ever use after this class if for some reason the work that you do doesn't actually involve databases. So I'm going to expect that you've learned Git, or you can learn Git through some other means. There's a bunch of linked tutorials from the website. I'll be recommending many of them if you aren't familiar with Git. I'm only going to talk about really the small bit of Git that you need in order to work in this class. Okay, so what is Git? Git is version control. It allows you to keep track of your progress as you write code, save it, and store it in a way that you can reproduce it, that you can share with other people. Now, how do you do this? Well, Git has 2 stages to making a commit. You use git add to bring the changes in your saved files into a place called the index, where Git keeps track of the changes you've made. And then you commit it is basically saying, here are all the changes, and you attach a commit message, a particular description of the changes you've made at that point. The exact process for how to do this, I'm going to expect you to go through the linked tutorial to learn on your own. Alright, so the big picture is your repository is basically a big graph of commits, each one pointing to the parent and what changes that they have made for each one. In addition to these commits are the white rectangles here. The numbers, or the hexadecimal numbers inside them, represent a hash of the content of the commit. Doesn't really matter for the purposes of this discussion here. And in red are various branches that point at a particular tag. So we have 2 branches, one called master and one called testing, both pointing at the same commit. Additionally, there's another little pointer called head, which tells you which branch are currently checked out. So right now, we have the master branch checked out. If you made new commits, it would advance the master branch. If we check out the testing branch, this is what it would look like. What this involves is saying, okay, if we made new commits here, what branch would be advanced? The testing branch would be. So let's imagine that we're working on this code base and we make another commit. And so after that commit happens, this is what the code looks like. The testing branch points at this new commit. That commit points at its parent. And master is now kind of in the past. It's pointing at a commit. It's not at the very tip of the graph of commits. Okay, so what happens if we want to incorporate the changes that we've made in the testing branch with master? Well, the first thing we need to do in order to change master is to check it out. So now we've checked out master, head points at master. And let's say once we're in the master branch, we've made some additional changes and we make a commit there. What would that look like? Well, it would look like this. So now we have a new commit that master is pointing at, that points at the old commit. Master is still checked out. However, we have this interesting problem now. We have some work that we've done on the master branch. We have some work that we've done on the testing branch. Often you want to combine those 2 lines of work into one commit that has all of the changes from both. So how do you do that? Well, that process is called merging. So here we have a slightly simplified diagram of our Git repository. There's also been made another commit, and I changed the names of the branches, but it's still basically the same idea. We have some work that's been done on one branch and some work that's been done on the master. If what we want to do is combine those 2, that's called a merge. So the way merges work is it's basically there's a common ancestor for both of those branches. In this case, it's C2. And we want to combine the changes made in C4 with the changes made in C3 and C5. So what we need to do is we need to make a new commit that merges those contents together. And the way that you do that is you run, while master is checked out, you run git merge, in this case, ISS53. And now your history will now look like this. Now this last commit, this commit that's now called C5, has 2 parents, and it's combining those attributes from both parents. In addition to just merging between branches in your local repository, it's also important to be able to work with remote repositories. What are remote repositories? Those are basically any repository that's not on your computer. Alright, so let's imagine we start off with, we have a company that has a particular repository, let's say hosted on GitHub. What do we want to do if we want to work on that repository? Well, that setup looks a bit like this. So at the top, we have a repository that's on some publicly available server, let's say. And when we want our own copy of that repository, we have to clone it. So here we do git clone and then the URI for that repository. And what that will do is it'll make a copy of that repository on your computer. It will have the same commits. And then in general, you'll have the master branch. And you'll also have another branch called origin/master. That remote that you just cloned is now called origin as kind of a shorthand on your local repository. So it's saying, hey, as far as I know, the master branch of the repository we just cloned is at F4265, as is your branch. All right, so let's imagine that we want to actually do some work in our repository. So what we do is we've made more commits and advanced their master branch so that it looks like this. However, if at the same time somebody has also made changes to the repository that we cloned from, the top repository will have changed as well. And note, those are different commits. You've made some work and somebody else has made different work. Okay. And so you might go, well, your repository is now wrong. Why? Because origin master is now not actually pointing at the right commit. The real master branch of the origin remote is at that 190A3, and your repository thinks it's still at F4265. So what do? Well, Git doesn't talk to the internet unless you ask it to. So what you do is if you issue a git fetch, it basically says, hey, communicate with the origin repo and update the state. So it will say, oh my gosh, look, there's new commits at origin that I don't have locally. It'll download those commits and it will update origin/master. Now note, origin/master is very different from your master branch. Oftentimes they're not pointing at the same thing. So what would you want to do in this case? Well, likely what you'd want to do is you'd want to run a git merge origin/master to combine your master branch with the origin master branch so that you have both of those contents together. Once again, the exact details on how do you run your merges and what merge conflicts are, how do you add remotes and all that, we'll talk about a bit later, but I'm going to expect that you actually learn a fair bit by working through some of the linked tutorials. All right, in addition to Git, one thing that's optional but highly recommended is the use of SSH keys. So when you're working in this class, you're often pushing and fetching from GitHub. And now, because you're working with private repos, or really just almost every interaction you have with GitHub, you have to be authenticated. You have to prove, I'm Josh, and here is my password. I have permission to either see and or change these repositories. And so when you're working with Git, you'll find yourself that you often need to have to authenticate yourself with GitHub. And so an alternative to always typing in your username and typing in your password is to use SSH keys. We'll, in the Project Zero description, it goes through the process of creating SSH keys. We'll cover that in a later video. But what the thing that these keys provide is basically a way to prove that this computer has permission to talk to GitHub on your behalf. All right, so the way that these work is you basically make a pair of public and private keys. And what you do is you basically give the public key to the computer that you want to prove who you are to. So usually you log in with your username and password, you upload your public key. And then every time you try to communicate to that computer through the terminal, what it will do is it will say, hey, I'm Josh Nahum. And the remote computer will go, okay, prove it. And it would basically make a puzzle that only the person with the private key could solve out of that public key. The exact details, you can take a class on encryption. We're not really going into it here. But the nice thing is this provides a nice automated way for your computer to prove that it has permission to talk to a particular server. All right, so multiple choice question time. What does the remote server, for instance, github.com, need in order to successfully authenticate you? Okay, so it's a kind of a trick question because there's multiple correct answers here. The minimum that it needs in order to authenticate you is either your username and password, like the old style. If you don't do SSH keys, it's going to force you to use username and password, or all it needs is your public key. You provide it your public key. You don't give it your private key. Your private key stays on your own computer. But through the process of SSH, there is a communication that goes on that allows the remote server with just the public key to be able to prove that you actually have the private key and that you are allowed to do this communication. All right. The last kind of piece of technology that I want to talk about for this class involves continuous integration. Continuous integration is this kind of relatively new phenomenon where the goal is every time you make changes to your repository, you want to run your tests and make sure that everything's working. Especially you want to make sure that you don't break something that's currently working. Basically what we're using in this class is that every time you push commits to GitHub, every time you make new commits on your computer and run git push, Travis CI, which is a company that we have an educational license with, will notice that you've changed your repository and will run the tests on your behalf. And then it can actually do is either you go to a particular web page or you can configure it to send you an email that says, hey, I noticed that you made a push and I ran your tests off of this commit. Here is the results. You pass these tests, you fail these tests. All right. Why am I having you guys do Travis CI in this class? The primary reason is it's the only real way to confirm that you are actually solved the project. So when you're working on these projects, you should be committing and pushing and doing stuff on your local computer. You should be running the test suite, making sure everything's working. However, even if the tests are working on your own computer, they may not work when we try to run your tests. The primary reason why you would have this discrepancy is that you may actually have work that you've done on your computer that you haven't actually pushed to GitHub. And of course, we can't reach into your computer or to your Arctic account. We can only see the things that you pushed onto GitHub. So what Travis CI does is it only is able to run the tests on the things you've set onto GitHub. So the primary way to work on this code is do the commits, do pushes, do the commits, do pushes. And then when you think you've passed all the tests, go to Travis CI and check and make sure that the commit that you think passes all the tests does indeed pass all the tests there. I'll show you how this works in another video. Okay, so the way that we're working with GitHub to turn in your projects for this class is that there are actually 3 separate repositories that you have to work with. Okay, so the first one is your private repository on GitHub. We will discuss this in the Project Zero description. It should have been made on your behalf. If not, you need to let me know through Piazza. The repo is named your MSUNetID-database. The important thing is that only you and the instructors can see it. So you don't have to worry about the code that you're pushing here being publicly available or being available to other students in the class. And the important thing is this is the repo that we grade. This is the repo that Travis CI tests. All right. The other repo that you'll be working with is the repo that's local, the repo that you're actually able to run Git commands on directly. So you'll be doing most of your work here. You'll be doing all the Git adding, Git committing, Git pushing, Git fetching, Git merging. All of that will happen at this repo. Now, I'm going to show you the instructions for getting this to work on Arctic. If you prefer to work with it on your computer, that's entirely up to you. However, that's not a mechanism that we'll be supporting. So I won't be giving you help on like, how do you get your computer to work nicely with Git? I'll just show you how to do it on Arctic. If you want to use Git elsewhere, that's entirely up to you, but that's not something that we're going to teach. And lastly, the third repo is the instructor database repo. This is a repo that only the instructors would be able to edit, but everybody will be able to see. So this is a read-only repository from your perspective. And what we use this repository for is to basically release code to you guys. So I'll make commits on the instructor database that would be including, the test cases and testing apparatus for future projects, project solutions, changes to the test suite, stuff like that. Those are all commits I'll make to the instructor database. And after I do so, I'll announce on Piazza to say, hey, project such and such has been released, fetch from the instructor database and merge it into your project so that you'll have the new code. And that's one really nice feature about using Git to handle this stuff is that you don't have to manually download stuff and make folders and make sure that all the files are named correctly and so forth. Git will do that on your behalf. And especially with Travis CI, it's very easy to see whether or not your code actually works.